This video will show an example of how to find the angle between two 3D vectors using the dot product method. In this problem we have two vectors. The first vector is vector A, which is 5i, 1j and minus 3k, and vector B, which is 1i, 6j and 6k. To find theta in this problem, we use the formula theta equals cos inverse vector A dotted with vector B over the scalar of A multiplied by the scalar of B. To solve for the numerator in this problem, we need to use the formula vector A dotted with vector B equals AX BX plus AY BY plus AZ BZ. In this equation, these variables are the coefficients of the vectors that we're interested in. This AX variable comes from the X component of A vector, which is 5. The B variable here comes from the X component of the B vector, which is 1. The AY comes from the Y component of the A vector, which is 1. And the BY comes from the Y component of the B vector, which is 6. The AZ comes from the Z component of the A vector, which is minus 3. And the BZ comes from the Z component of the B vector, which is 6. When this is calculated, it equals minus 7. To find the scalar of A, or the magnitude of A, what we need to do is use Pythagoras' theorem. We take each one of these coefficients of the A vector and square it and add them together, then take the square root. Therefore we have 5 squared plus 1 squared plus minus 3 squared. When you calculate this, you get root 35. You do the same for vector B. Take the square root of 1 squared plus 6 squared plus 6 squared, and this equals root 73. Finishing this problem off, we pretty much just substitute everything back into this original formula. So the minus 7 goes into here, and root 35 and root 73 go into here. Therefore, the formula will be rewritten as theta equals cos inverse minus 7 over root 35 root 73. You put this all into your calculator, you should get an angle of 97.96 degrees. And this is the answer.